Okay, so we have a practice problem looking at the speed of a longitudinal wave. We're going to use echolocation, that super cool property that various animals have, like marine life. So imagine that a dolphin who has the ability to use echolocation, sending out a sound wave in a medium of the water. So this is that longitudinal wave in the medium of seawater. That dolphin sends out a wave with a frequency of 100,000 hertz. So we want to know if an object is 100 meters away from that dolphin, how long does it take for that dolphin to hear the echo of that object when they can identify it? So we need to know a couple of things in order for us to answer this question, a few properties. We need to know the bulk modulus of seawater. Again, if we're dealing with a longitudinal wave, then we look at the elastic properties of the medium, and we're dealing with that fluid, and so we're going to use the bulk modulus. The bulk modulus of seawater is 2.09 newtons per meter squared. The other property that affects wave speed, of course, is the density. And so we also need to know the density of seawater, since again, that is the medium the object is, or the sound is traveling to, and that is 1.025 kilograms per meter cubed. So there are the two constants we need to know in order for us to answer this really fun question. Okay, so how long? How long? Well, that's kind of a kinematics problem, right? We want to know how long does it take for the sound to go to the object and come back from the object. So we're told in the problem that the distance of the object is 100 meters. But to go to the object and come back, we know that sound will travel 200 meters. Okay, so it has to get there and it has to come back. So the sound travels 200 meters. We also know that to get how long that sound travels, it's going to be traveling at a constant velocity in the medium. So the velocity of the sound is a constant in that medium, right? We've talked about how in a certain medium, sound waves will travel at a constant velocity based on that medium. And we know that the velocity from our kinematics unit is equal to the distance over the time. So this tells us for us to find the time, we need the distance, which we have, and we need the velocity of the sound. All right, so this guy, that's what we're interested in determining. What is the velocity? To answer our question, what is the velocity of this wave? Perfect. All right, so let's solve that. Let's remind ourselves that the velocity of a wave, longitudinal wave, in a fluid is equal to the square root of the bulk modulus divided by the density. So I have everything I need to solve this part of the problem. The bulk modulus is 2.09 newtons per meter squared. The density is 1.025 kilograms per meters cubed. If you want, I encourage you to go do that dimensional analysis to make sure we end up with meters per second after this calculation. And when we plug this into our calculator, we find that the velocity is 1.4 times 10 to the third meters per second. Once I know my velocity, can plug that into my time equation. So I have my time is equal to, again, the distance over the velocity. All right, so my distance, we said the object's 100 meters away, but again, the sound has to get there and come back, so the distance is 200. My velocity is 1.4 times 10 to the third, and I get a time before that dolphin knows of 0.14 seconds. All right, so that concludes this problem. So understanding that we're dealing with an object moving, or sound, excuse me, a wave moving through a medium. In this case, that medium is seawater. That's a fluid. We're going to use the bulk modulus in our velocity equation. We also, of course, need that density. It's an echo, so it has to go there and come back. Small little nuance there. And we can use our kinematics with our wave information to determine the time. Good job.